Welcome back to the channel for another video in the COVID-19 series. Last time we did the Pythagorean theorem. Today we're going to be doing some trigonometry. Sounds complicated, but it's not. It's really fun to just be talking with your family, like, oh, what did you do today? Well, I did this and this and this. Oh, well, I was doing some trigonometry, and they're going to be like, you were what? Like building the next rocket, going to Mars? What are you doing? No, it's not that complicated. The actual definition of trigonometry is the branch of mathematics dealing with the relations of sides and angles of triangles and with the relevant functions of any angles, which is a super fancy way of saying sine, cosine, tangent. That's what that means. Because sine, cosine, tangent, they're ratios for each side of the triangle and then the angle of the side that you're looking at specifically. That's all trigonometry is. It's the study of the patterns between sides and angles in triangles. Again, this only works on right triangles, just like Pythagorean theorem. You're not going to be able to do this sine, cosine, tangent on other triangles. There are ways you can get the side and angle lengths on triangles, like the law of sines, law of cosines, stuff like that. But we'll do that in another video. Today, we're just going to be looking at these three. So, what are sine, cosine, tangent? Well, sine is going to be this. So you'll have sine of an angle. So like sine of angle x, it's going to be the opposite side over the hypotenuse of the triangle. Cosine of an angle is going to be the adjacent side over the hypotenuse of the triangle. And the tangent of an angle is going to be the opposite side over the adjacent side in the triangle. This will make literally 1,000 times more sense once we see a triangle, but you have to memorize these just because you're just going to have to know them. And a super easy way to memorize them is using this acronym, SOHCAHTOA. This is how I memorized it. It's super easy. What I like to do is just, you go and do a test. Let's say you're getting tested over this stuff, and immediately you write your name down, and then right beside your name, you write SOHCAHTOA. Just write this right here, SOHCAHTOA. And all this stands for is S, right? Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. SOHCAHTOA. And you got all these ratios memorized, written down. You're ready to go ace the test. Bingo, no worry. So moving in to the actual measurements. First, we got sine of x is b over c, right? Opposite over hypotenuse. Hypotenuse is going to be the longest side across from the right angle on the triangle. So you're going to have the opposite of sine x, which is this side down here, b over c. Now cosine of x is the adjacent, so a, right here, right? It's the side that x is touching that's not the hypotenuse. So adjacent is a over c. And tangent x, it's opposite, which is b over adjacent, so b over a. Next, looking at angle y. The sine of y is going to be opposite a over the hypotenuse, which is c, a over c. Cosine of y, the angle it's touching, it's going to be b over the hypotenuse, c. And tangent of y is just going to be the opposite, a over the adjacent, b. Now, a cool thing, and you'll already start to see patterns here. Check this out. Sine of x is b over c. Cosine of y is b over c. They're the same. Cosine of y and sine of x are the same. And then cosine of x, a over c, is the same as sine of y, a over c. It's the exact same. And then the tangents of x and y, it's just flipped around. It's just b over a for tangent x and a over b for tangent y. Super straightforward. So like I said, these things are full of patterns. You just have to know how to find them. Moving into our first example with numbers. We just got a 3, 4, 5 right triangle. So first of all, sine of x, opposite over hypotenuse, 4 over 5. It goes to about 0.8. Cosine of x, we got adjacent over hypotenuse, 3 over 5. And tangent of x, we got opposite over adjacent, 4 over 3. Sine of y, we got 3 over 5, opposite over hypotenuse. Cosine of y, we got 4 over 5, adjacent over hypotenuse. And then tangent of y, which is 3 over 4, opposite over adjacent. Easy money, easy test points, easy stuff. Moving into the next example. These ones, you're not going to get out to be as perfect numbers. I mean, look back here. We had 0.75, 0.8, 0.6. This is our only weird one, but I mean, it just goes at threes forever, so it's not really that weird. And then 0.6, 0.8. Easy. This one's going to be a little bit trickier. You're going to get some crazier numbers. Check this out. You got 12 over 13, 0.923. It's not just a super easy. 5 over 13, right? Adjacent over hypotenuse, we got 0.385. Tangent of x is 12 over 5, 2.4. Opposite over adjacent. Sine of y is 5 over 13. We got cosine of y is 12 over 13. We got tangent of y is 5 over 12. Super, super simple. And again, you can see these patterns. Cosine of x and sine of y are the same. And cosine of y and sine of x are also the same. So here's the monster problem. All we know is that this angle right here is 30 degrees and the hypotenuse is 10. And it wants you to find this side down here. Now we can't use Pythagorean theorem because we don't know this side. We don't have a length here. So we have to use sine, right? Opposite over hypotenuse. So the sine of the angle 30 is the opposite question mark over hypotenuse, which is 10. All right, how you get here is just going to be to type this into your calculator, look it up, what sine 30 is. Sine 30 comes out to be exactly 0.5. This is super, super important. Not all sine of whatever angle is going to come out to be just a straight up number like 1/2, like sine 30. Sine 30 comes out to be this equal or this even just because of it's a special right triangle, which we'll also get into in another video. But most of the time, you're going to have a crazy irrational decimal that goes on forever. This is just an exception. So don't freak out when that happens. It's supposed to happen. This is a rare example. And we can simplify this just using algebra, multiply 10 over here, multiply by 10 over here to move it to the other side. We got that question mark equals 5. So we can change that. Ready? Boom. Into 5. All right, so let's say your teacher woke up on the wrong side of the bed, right? Or maybe your class has just been goofing around the whole week and your teacher just wants to punish you. And he says, all right, you're not done. I want you to find this side. All right, you found this side. I want you to find this one. Well, easy. We have this side length now. We can just use Pythagorean theorem. Game over. We got question mark squared plus 5 squared equals 10 squared. Remember, just like yesterday, a squared plus b squared equals c squared. We got the question mark squared plus 25 plus 100 equals 100. Question mark squared equals 75. Question mark is about 8.66. So from all that information, or from just this information, right, all we knew was the angle and we knew the hypotenuse. We got this. That's crazy. We got this side, we got this side. We filled in all the sides on the triangle just from knowing an angle and the hypotenuse. That's pretty awesome. So yeah, that's about it. Thank you for watching. If you are enjoying the content, feel free to drop a like and subscribe to the channel. It'll help us out. Again, I'm doing these just to help out some fellow geometry students during the current pandemic and making sure that they can still get all of their work in, and if they do need help, that they have a place to go. And with that, I'm out. I'll see you in the next one.